for another episode of Math with Mullins. Today we're looking at lesson 1.3, which is talking about line segments. So what we're going to be able to do today is calculate measures of line segments and then also be able to look at line segments to determine missing values and apply that definition. We're going to get started with two vocabulary words first, and then we'll do some more terms later on. First, we're going to talk about a line segment. So let's look at a picture first, and then we'll talk about a definition. So I'm going to go and draw a line segment. And I'm going to have some points, let's say X, Y, and then Z. And a line segment is a measurable part of a line and consists of two endpoints and all points in between. So, and how we're going to name this is we're just going to use the endpoints. This is line XZ, and what we're going to do is just put a line on top of that. That just stands for line segment XZ. So use two endpoints to name. Okay, betweenness of 2 points is going to talk about the measurable, the measurability of this. So you'll have any two real numbers like A and B, and then any number, let's say the number N, between A and B is A less than N less than B. And so what that's going to look like is maybe you have this number line and you have the numbers 1, 5, and 7. This could be standing for letter A, this could be letter B, and then N is in between. So that 1 is less than 5, which is less than 7. Okay, that's all it's going to look like. So you're going to think about this in terms of a number line whenever we start talking about distances. Let's go and make sure that's copied down. You can pause the video here, and then when you're ready, let's keep playing on so we can see our example number 1. This is going to be a pretty easy example to start off with. To find the measurement of XZ, that is the two endpoints from X all the way to Z. So all I got to do here is add 11.3 and 3.8 together, and I'm going to get 15.1 centimeters. Example 2, if you want to pause this, you can go ahead and try it on your own, but find the measurement of RT if you know RS is 12.4 and ST is 25.3. Something that might be helpful for you here is to go ahead and label RS is 12.4 inches and ST is 25.3, so we're still adding these two together. So 12.4 plus 25.3 is going to give us 37.7 inches. Make sure my decimal's showing up good. Okay. This next one you can pause on and try on your own. Example 3, find the measurement of PQ with the given information. One thing we notice here is PQ is missing, but we do know the total amount, 24.3, and we know partial amount, 17.8, so we're just going to find the difference between those, and we're going to get 6.5 centimeters. Okay. Next up, we're going to see some algebraic expressions, writing an equation with that, but also drawing a visual for us. So right now it says find the value of X and BC. So we're going to find two things. This is part 1 and part 2. If, this should say if, B is in between A and C. So let's go ahead and draw a line segment. Doesn't need to be perfect or drawn to scale. So it says B is between A and C. So that means AC is the endpoint. And it says AC is 4x minus 12. So this entire length is 4x minus 12. AB is equal to x, and then BC is 2x plus 3. So one way we can do this is maybe write an algebraic equation to represent what's going on. I know that AC is 4x minus 12. That's the entire length. That should be equal to my two line segments added together. So AB is x plus my BC, which is 2x plus 3. Okay, so here's AB, this is BC, and this entire thing would be AC. So I'm going to combine some like terms, x and 2x makes 3x plus 3. My left side over here, 4x minus 12, nothing combined here, but now I'm going to start moving some variables. I always try to move the variable that is smallest, the smallest coefficient variable first. That way I don't have to worry about too many negatives, and then obviously moving my constants to the other side. So I'm going to get 1x is equal to 15, so part 1, x is equal to 15. And then to find BC, I'm just going to plug in that 2x plus 3 algebraic expression. I'm going to plug in my 15 where my x is. 2 times 15 plus 3 gives me 33. Okay? Second half of notes, now we're going to talk about some congruent segments. So congruent just means two geometric figures that are exactly the same shape and size. Okay? You can also use congruent with this little symbol. You probably saw that in maybe algebra, but there's also another way to show that too. Let me just show you a few examples. Here are two congruent squares where you would have the same amount of tick marks on all sides. Okay? We're going to use that tick mark when we talk about congruent segments, meaning we have two segments that are the same measure. Okay, that can look like this. Maybe I have line segment AB, and I have a tick mark in here and it says 1.7 centimeters. And then maybe I have segment CD. Also going to have one tick mark, also representing 1.7 centimeters. So as long as you have a matching tick mark, that usually can indicate the same measurement here. Now we're going to use that information and try some examples. We have 3 more examples left, so let's go ahead and finish this out. We know that this line segment is being cut into 2 sides. We have F to G and G to H, and notice that they have the same 1 tick mark. So these should be equal to one another. What maybe we can even label these as is FG could be letter X, and GH could also be the letter X. So X plus X could be equal to 14.2, or 2X is equal to 14.2. So really we're just dividing 14 by 2 by 2, or cutting it in half essentially. So X is equal to 7.1 here, or FG is equal to 7.1 millimeters. Okay, now you didn't have to write the equation there. I realize you can say, oh, I know 14.2 could be cut in half, and I can get my 2 congruent segments that way. Why don't you pause the video here and try example 6 on your own, and when you're ready to check it, go ahead and click play. All right, this one's kind of nice because it already has a visual for us. It says find the value of x if q is between point P and R, and PQ is 6x plus 20, and QR is 2 parentheses 6x 2 parentheses x plus 6, and that PQ is congruent to QR with their congruent segments. So since I know they're equivalent, I'm going to go ahead and write down 6x plus 20 is equal to 2 parentheses x plus 6. What I'm trying to do is solve for x. Let's go ahead and combine any like terms with distribution here. 2x plus 12, 6x plus 20 stays the same. And then I, again, like to just use the smallest coefficient, move that first to try and eliminate any negatives, but it looks like I'm going to get a negative anyways here. That is okay here. So I'm going to have 4x equals negative 8, and then divide both sides by 4, x is equal to negative 2. It is okay sometimes if you get a variable equivalent to a negative answer. That just means, even though I'm measuring distance, if I plug in the negative 2 here, I'm still going to get positive results. I'm still going to get 8 as my segments. And our last example, again, if you can, go ahead and pause the video here, try this on your own, and when you're ready to check it, click play. All right, find the value of x if u is between t and v. Since there's no picture, I'm going to go ahead and use some problem-solving skills and write down u is between the letters t and v. Tu is 7x plus 35. uv is 4 parentheses x plus 7, and they are congruent. So I'm going to add my tick marks in there as well to show that. Since they are congruent, let's write 7x plus 35 equals 4 parentheses x plus 7. Let's go ahead and distribute these. So 4x plus 28, and then 7x plus 35. Again, I'm going to try to move that smallest coefficient. Try to not deal with negatives, but again, I think I'm going to be stuck with some, and that's okay. So I've got minus 4x. What was I doing? 7x minus 4x is 3x equals 28 minus 35, negative 7. And then if I divide here to get x by itself, I'm going to get a decimal. So we're just going to leave it as an improper fraction. Negative 7/3 would work just fine for your x. Okay? That is going to conclude our lesson on 1.3 line segments. Thanks so much for tuning in, and we'll catch you next time. Have a great day.